All right, 9-5, day 2. Okay, just so you guys understand again, we got day 2 today, 9-6 tomorrow. It's only one day. It's pretty short. And then 9-7 is Monday, Tuesday, and then Friday, Monday, and then we are done with the chapter 9. Okay, so we're looking at probably next week at some point, either Wednesday or Thursday, for your test on the last half of 9, and then we go to 7. And chapter 7, just so that you know, is only 3 sections and it's done. It's really, really short. Okay.
I'll be gone this Friday.
And yeah. End of the 9 weeks again is tomorrow. So if you're missing anything, make sure you get that to me as soon as possible, like today, if you want it to affect anything that you have outstanding right now. Because tomorrow at 8 a.m., grades will lock for 24 hours. Just so that you guys are aware of it. Okay? Okay. So the last 2 types of graphs that we're going to look at on 9-5 is the secant and cosecant curves. Okay? So we've got the same type of scenario, secant of, I forgot the b, bx, and the cosecant. Now, quick question for you again, just to remind you of what happened in the first part of the chapter. Secant was the reciprocal of the cosine, good. And secant or cosecant was the reciprocal of the sine. So what's going to happen on these is that we're going to have curves that are not going to be like the snake curves that you stuck your hand out the window for. But they're going to be based off of those. Okay? So just so that you are aware of it. So getting back to some things with this, period. Remember, this is a different period than tangent and cotangent. Period, again, we had for these was 2 pi over b. What's the A stand for? Not the period. A dealt with the B, the amp. Okay, what was the amp again? Like how high up or down it went, right? Okay. So we're going to do stuff like this, and I'm going to draw in different colors just so that you guys understand. When I do a secant, when I do a cosine or a cosecant curve, I'm actually going to draw in the sine and cosine curves. I'm going to put those in, what color do you want me to put the sine and cosine curves in? Green. And then the secant and cosecant ones, I will be drawing those in black. Just so that you guys know, those are the answers that we're actually looking for. If it helps you, draw the sine and cosine curves in. If it doesn't help you, then you don't have to do those. Because realistically, when you're drawing the cosecant and secant curves, those sine and cosine ones are not there. But I'm going to draw it as an aid for you. Okay? So, here's what we got. First one is g of x equals 2 the secant of x. So, I want you to identify a couple things for me, if you would. What's the amp? 2. What's the period? Two pi over 1. Because there is no number in the b spot. This is where the b should be. If there's not a number there, it's understood to be a 1. So our period is 2 pi. Notice, no shifting. Right? What if there would have been? Then we would have also said left or right, up or down. So, here's what I'm going to do. Is I'm going to draw in, and you said you wanted me to make the cosine or the sine curves in green, right? And then the real ones, the answers were going to be in black. So why did I put the 2 pi out there first? That's my period. What's half of 2? 1. What's half of 1? Half. And what's halfway between 1 and 2? 3 pi over 2. You guys are pretty good about that now. First couple times you didn't know what to do, and now look at you. Yay. Okay? Again, in order to do that, an easy way to get it is, once I cut it in half down to this part here, and this is what I was talking to Savannah about on the other one, a half plus a half plus a half is 3 halves. That's how I got it. Okay? Now, what is the reciprocal of secant? Cosine. Right. So I'm going to draw a cosine curve. So 1, 2 up. Here's my amp. 1, 2 down. There's my amp. Where does the cosine start at? Does it start at the amp or does it start at the midline? Cosines start at the amp. Okay? So point 1, 2, 3, 4, and 5. This is what a cosine curve should look like. Right in here, coming in here, hitting there, and out the door. Again, the green one is just a reference. It's not part of the answer. So when you're drawing your answer, if you need to have that in there, I would suggest that if you make it really nice and light. Because really that's not the answer. Here is the answer. Now what I want you to do is, I want you to run vertical lines at the places where it hits the midline. Where did the green curve hit the midline? Half of a pi. 2, 2, 2, 2, 2, 2, 2, 2, 2. Vertical line. Where else did it hit it? 3 pi over 2. 2, 2, 2, 2, 2. 2, 2, 2, 2, 2. And now, here comes me drawing the graph. Here's the actual curve for these. Now, one thing that I want you to identify with this is, do you see how from half to 3 halves, how far is that? 1 whole, right? So what's 3 halves plus a pi? What's another half out here? 5 pi over 2. How'd you get that? I heard someone say, how'd you get that? So how'd you get it? You added a half to 2. Right? Good. Now, here's how it works. Every place where it hits the amp is where my secant curve starts. Secant curves do not flow like your hand outside the car window. Secant curves flow in between them, and they look like mini parabolas. So what I mean by that is, this is the secant curve coming in here. Notice how it's touching the green ones. Oops, I went too far for that one. It's touching the green ones, but it's not going past those vertical lines that I made. Those vertical lines are known again as asymptotes. Asymptote is like the invisible shock collar for the dog. You can come right up to it, but you can't go over it. This is what a secant curve looks like. Guess what a cosecant curve looks like too? Looks like one of these. So for me personally, the green curve up here realistically is not there. Okay? That green curve is not there. But the reason why I put it there is to show you that that's where it hits the points. That's where the cosecant curve or secant curve would go. If you don't have to draw it, you don't need it. Realistically, remember when we talked about what points and we talked about on the midline? Points 2 and 4 were on the midline and points 1, 3, and 5 were on the amp. Remember that little chart that I had on there? If we knew that, could I just simply put the dots on there and that's where I go up or I go down? Yeah, I could. I'm just showing you one other technique as far as putting the extra curve in there to help you. Okay? That black part, though, is the answer, not the green. The black part is the answer. You are going to be asked to draw 1 period's worth. What's a period's worth? 2 curves. I drew 3. 2 curves is a period. Okay? So I actually put an extra one in there just to show you that it just keeps going like that. But realistically, 2 curves is all you need. Okay? What's the most important thing that you guys can do on these curves? Making the shape is easy. And some of you guys just made the shape on your homework. You just went and just drew a little. A lot of you just did this on homework stuff. You said, oh, it goes like this and it looks like this. Well, my 6-year-old can do that too. Okay? He can make curves like that. But what's more important with this? The labeling, the fractions. That's what you need to show. Some of you guys are missing that. Make sure you label. Labeling is important. Hey, next one. Hey, this one's a cosecant. Which one's this the reciprocal of? Sine. Good. So let's get the period. What is in the B spot? What happens when you have pi on top of pi? You get a stomach ache, right? And you end up throwing up all over. Okay? So the pi's cancel, so my period is 2. What's the amp? The amp is a half. Good. Do you want me to draw the extra green graph in there so that you can see where it hits? Some of you yes, some of you no. I'll put the dots on there first, then I'll put the green in there, but you don't have to if you can do it without it. How far out do I go? 2. Far enough, but then as long as I label it 2, right? What's half of 2? 1. What's half of 1? Half. What's halfway between 1 and 2? 3 halves. What's another half past 2? 5 halves. How high up do I go? I go a half, right? So my amp is right here. When I was a cosine curve, no, not cosine, sine curve, did sine start on the midline or did it start at the amps? Sine is midline or amps? Midline. So it starts here. So, remember what I said on the last one where it hit the midline? That's where the asymptotes go. So my asymptote is every place it hits the midline. So there's an asymptote. When I made a sine curve, it started here and then went up to here. When it's on an amp, you don't make a vertical line. When it's on the midline, you make a vertical line. Then at 1, you would have hit the midline. That's 0.3. So, vertical line. At 3 halves, you would have hit down here for a sine curve. Do I make a vertical line there? No. Then I would have hit back here at the end of the period. Do I make a vertical asymptote when it hits the midline? Yes. Anytime it hits the midline, I make a vertical line. So remember when we talked about which one it hits? Sine curves hit it at 1, hit it at 3, and it hit it at 5. And it hit the amp at 2 and at points 4. Anytime it hits the midline, that's when you make your vertical line. Regardless if it's secant or cosecant. And now I make my curves. The first curve. Does my first curve go up or down? Where'd this hit? It hit on the top part, so it goes up. Where does the next part go? Down, because it hit down at the bottom end. Right. Is that all I need to draw? Yeah. Now, for some of you that wanted me to put the sine curve in there, did you see it was there? I just didn't draw it. I just didn't put it in there. All I did was put the dots on there. Okay? Anytime the green graph hit the midline, that's when you make vertical lines. Okay? You are not going to be asked for it to be shifted up or down any. Or to the left or right any. Everything's going to be okay with that. It's not going to have any of them that are shifting to the left or to the right. None of them are. The only thing that's going to change is the length of the period and the amp. That's it. All it does is it makes little mini parabolas where it hits the amps. That's all it does. Wherever it hit the amp is a mini parabola. Hit the amp, mini parabola. Hit the amp, mini parabola. Hit the amp, mini parabola, and so on. So on the first part of your assignment, it says graph one period of the function. Describe the graph as a transformation of the graph of its parent. By you telling me the period and the amp, you're telling me the description. And then the last part of your assignment is matching. It's just asking you to match them. Okay?
That's a good one.
Can you do that?
That's a good smiley face.
So on page 502 to 503, 18 to 24 evens, and 29 to 34 all. Those last ones, from 29 to 34, they're just matching. They give you the actual equation, they give you a picture, match the picture with the equation. You will have tangent and cotangent involved in those. On the 18 to 24, that's cosecant and secant. There's two of each. Just like the ones we did in class. Are you guys okay?
No.
We'll see.